Hello, so today I will be talking about wormholes. And in order to understand wormholes, you need to understand an extremely important topic known as general relativity. Now, general relativity is just a fancy 20th century way to say gravity. So, gravity is the force which pulls two objects towards one another. That's basically the great explanation leads up to this: why two objects are attracted to one another. Like why don't we float into space and why are we still on the ground? That is gravity, or why the Earth is orbiting around the Sun. That is also the reason gravity, why humans are still on Earth rather than floating in space. Now after this it's gonna get a little difficult because then Albert Einstein came along, and unlike Isaac Newton, his universe was like a huge wooden stage. Like a stage, and it was eternal, everlasting and unchangeable. And the objects on top of it were just there. However, when Albert Einstein came along, he discovered general relativity. And general relativity, as I said, is gravity, but in that, he's discovered that gravity is due to space-time. And space-time is basically how the space is like. Now, for example, space-time is basically the fourth dimension. And the space-time is basically that time is a physical dimension. It's who it got discovered, and it was by Isaac Newton. Now, Isaac Newton was a brilliant scientist, and he discovered lots of things like the ray of the spectrum. Over here, okay? And it's going down, it's pulling the rest of the things towards it, okay? And now, it basically causes a type of, as you see, a fluctuation around it. So it looks like like what it would look like if you put a heavy ball in the center of a trampoline. That's what it looks like. Now if we go back to it, now imagine why is that Earth is orbiting around the Sun, the question which I posed earlier. That is now basically I have the Earth in my hands. I can't see it, and then I throw it, and you see it's orbiting around the Sun. So this is basically how everything works in the universe. A heavy mass object like the Sun or the Earth go on the space-time this is really important. Do you know space-time is a pseudo-Riemannian manifold? Which sounds really difficult, but actually it just means that it's locally flat. Like as I showed you before, there was any mass on top of it, like you put the Sun, it was just flat. And that's how it is. But unless you put a heavy massed object like the Sun or the Earth, there would not be a curvature of the space-time, which would cause other masses like the Earth to orbit around that heavier object. So every time the denser or heavier object is what is the lighter object always rotates around the heavier object. Like the Moon orbits around the Earth, and the Earth orbits around the Sun. So you see, the Sun is heavier than the Earth, and the Moon is less heavier than the Earth. So that's basically space-time. Now, you might ask, how in the universe is this related to wormholes? Wormholes are supposed to be portals. This is supposed to be a bunch of, useless knowledge, some would say. However, this is very important to what some call in fan fiction portals. So if you really want to create a way to reach your toilet when you're too lazy to get up from your bed, this is a really good way. So trust me, physics is useful. Now, in order to do this, there's a space-time. Now, as you see, space-time can be bent, which means it can also be broken, and it can be ripped. The space-time could be ripped apart from one another, which is what caused the theory that wormholes can actually exist. Because basically, wormholes are portals which connect two separate points in the space-time continuum. So, in order to understand the space-time continuum and in order to understand how wormholes work, you need to understand that three types of wormholes which are possible according to many scientists, and those three types of wormholes are Einstein-Rosen-Bridge wormholes, the string theory wormholes, and the man-made wormholes. Trust me, the third one sounds like a disaster. Now, the first Einstein-Rosen-Bridge wormholes are basically, as you can see, were the first ever wormholes to be discovered, and they were basically each black hole. Now, I'm pretty sure you heard of a black hole which is at the center of the Milky Way galaxy, which I don't know why it's named Milk. Like, there's no milk in that galaxy. Like why? In the center of the galaxy, and there's a massive black hole, and that black hole is caused by when a star collapses upon itself and causes an infinitely small object, smaller than an atom. Like imagine the entire mass of the sun into a thing which is smaller than the atom. And then what happened was that it basically curved the space-time so far deep. Basically, this is the space-time which you can clearly see, and that's the singularity. It goes so deep, like it's just literally causes a black hole. And the black hole is basically, you might think it's black, but it's actually like this. Whenever you see a black hole, you see a whole massive like circle where you can see a bunch of things. But actually, what causes everything to orbit or rotate around that is the singularity. Like the same way as I said, the sun makes the other Earth, like the Earth, orbit around it. The singularity is so dense that everything in the black hole is actually just orbiting or around singularity, like around singularity, like as it is so deep. So now we'll go into the wormholes. So basically, according to the Einstein-Rosen-Bridge wormholes, is that each black hole actually is a connection to another white hole. So this is where interesting times, this is where interesting things happen. This is the black hole and it sucks everything in. But in an alternative universe, there are things which are sucking it out. Those are known as white holes. And in an alternative universe, time runs backwards. Like time runs backwards. Like right now, if we're going into the future, then we'll be going into the past. That's what the alternative universe is like. General relativity is a set of mathematical equations which gives a lot of solutions and a set of different answers. So, like the thing is that general relativity does not prove that wormholes exist. It just makes that wormholes are possible. And even if it was, if a human was to go into the black hole, and if the Einstein-Rosen-Bridge wormholes were actually correct, then the thing which will be going out of the white hole, you won't be the thing which is going out of the white hole, but instead you'd just be dead. So that's a useless option to get from your bedroom to the toilet. Like you can't do that with this. You'll just be dead. And so basically, for example, show the sun over here, and now in here there is a curvature of space-time. You see, the space-time around it gets curved as the mass. Which is what causes gravity dead. So the second type of wormhole is string theory wormholes. Now these wormholes are if string theory or a special variation of string theory is correct. And this explains when the Big Bang happened. There were basically a bunch of quantum fluctuations, and those quantum fluctuations caused holes, and those holes were connected by strings, and basically in a millionth of a second, maybe even smaller than that. And after that, they were suddenly it expanded so massively. Like even do you know when the Big Bang exploded, it traveled even faster than the speed of light itself. Like as for currently, the fastest thing which can go is the speed of light. But when the Big Bang exploded, it traveled even faster than the speed of light. So really amazing. But this also causes that there are a bunch of wormholes that. So this actually might mean that we're lucky, and there are a bunch of wormholes just attached to one another and are separated by the huge and vast universe, and they're just waiting to be discovered by humans. Scientists suggest that there are actually black holes in the center of the Milky Way galaxy, and those black holes might actually be a wormhole, as wormholes and black holes look very alike from one another. So that's and basically, however, string theory wormholes are extremely quite unlikely. So let's get it, and you won't actually be able to travel from it, and humans won't be able to travel like we hope, and we can't go from when we're sleeping in a cozy bed and we don't want to get up, but we still need to go to the toilet. You can just get a portal, and the portal will cause you to just go into the toilet, and Yeah, really, really good. So all you need is a, like if you want to sleep in a cozy bed and go to the toilet, the string theory wormholes do not do that. So let's go on to the third and final type of wormhole that we'll be talking about today, and that is man-made wormholes. Now, trust me, man-made wormholes literally sound like a disaster because of two reasons. Mostly because either it will just destroy all of humanity, second, it will just suck up the entire universe, and the world will end. So, but if there's a third option, which is the only good one, is in which we actually succeed. But in order to actually create a man-made wormhole, you need to set special criteria. One of it is it's supposed to be transversable, which means that it's supposed to be connected from one point of the space-time continuum to the other. Basically, if you enter from one wormhole, from one part of the portal, like I'm just gonna say portal. If you understand, one part of the portal, you get off from the other one. It can be in the same place. So as for the final and last wormhole, which I'm gonna be discussing today, it's gonna be the man-made wormhole. And in order to make the man-made wormhole, you need a special set of requirements. The first requirement being that it needs to be on two distant points of a space-time or the space-time continuum, like between the bedroom and your bathroom, or the Earth and Mars and Jupiter. Like it needs to be at two distant points on the space-time continuum. And the second reason is going to be that there needs to be no event horizons for two-way travels. The third reason is going to be that it needs to be sufficiently sized so it does not kill humans who travel, as otherwise it would be pretty much useless. So, and the fourth and final reason, and the most difficult reason, is that it needs to have to open the wormhole. Like the string theory wormhole, the way it remains open is by a cosmic string. However, in order to keep this wormhole open, you will need a new type of matter. Like gravity is always trying to close things apart. Like otherwise the two distant points. Basically, I'm gonna call this portal 1 and portal 2, connecting two different points. And then the portal 1 and portal 2, the space between it, it basically is continuously trying to get tangled and the gravity is trying to block travel from the portal number 1 to portal number 2, or portal number 2 to portal number 1. And so basically for the wormhole to keep open, as I said, for the string theory wormholes, what keeps it open is the cosmic string. However, for the man-made wormholes, what we need in order to keep it open is a new type of matter which hasn't been discovered yet, known as exotic matter. So antimatter and matter, which is going to be a different video, have a positive charge. However, exotic matter has a negative charge. So instead of attracting things towards one another, it repels things instead of apart. So the exotic matter is what will keep the wormholes open. And if we're able to create the exotic matter, we're able to have all these requirements. All we need is to actually create the wormhole. Then you'll finally be able to go from your bedroom to your toilet when you don't want to walk to the toilet. So I guess that's the end of the